So let's see. All right. Hello, everyone. My name is Tony Sparks, and this is session 5 of Don't Block Me, Block You. In this session, we're going to talk about specifically in the last session, we uploaded some data, form data to the blockchain. It was a front-end application. We used MetaMask to do it. It was very awesome. It was very great, very great. And you know, you can do front-end stuff, MetaMask. The value of that stuff is that when the data is entered into the blockchain from a signed MetaMask transaction, there is no question that like the data that you put on the blockchain was added by that person specifically. If you're like building an application and you want to say, hey man, I want to just like remove all accountability. I know this is my database and I can do website stuff, but when this data goes into this blockchain, this was literally by a third party, someone else, right? And so that's the value of having signed transactions with MetaMask. I really feel like at some point contracts will kind of work that way. Instead of DocuSign, it'd be like block you sign. I'm coining that phrase, like right here in this video, block you sign. So all that being said, so that's like the last video, that's the value of MetaMask. But like in uploading code, to the backend, sometimes, you don't have MetaMask, but you still have to do the stuff of sending signed transactions. And this was some of the hardest stuff that I had to like do. And you're super lucky because I'm here to teach it to you. I did all the hard stuff. I went into the mud. I got the jewels. I got the diamonds, and I brought it out. And I'm just like, yo, man, you guys want to see how jewels and diamonds work? That's what I do. Don't block me, block you. So, the format of this video is I want to clarify what's going to happen, right? So we are going to create a token when someone signs up, right? Basically, crypto kitties, crypto zombies, stuff like that. Imagine every one of your users has their own like badge or card, or like 721 token, right? And so like when they sign up, we're going to create this. And then basically the flow of the code is we add a token. We create a token in our database. And then like we add a token uses some blockchain functions, calls to Web3 into the blockchain, specifically Ethereum. I don't want to keep saying blockchain like they're all the same, right? Ethereum. And then we have the modals. I'll show you guys that. And then I have this nice mint function that's actually used to kind of send the information to the blockchain. And then I have a cron job, which is pretty cool. Sales.js has like a nice little cron job plugin. And cron jobs, for you guys don't know, is like, let's say every, minute, every second, every hour, once a day, you want to run a specific function. In this situation, this cron job is going to mint or check to see for tokens that need to be minted, right? And then if it needs to be minted, it mints it, meaning it adds it, the token. It runs the call to the blockchain, say create a token, and then it does it. And then, now here's something that's really cool, right? The concept of listeners, right? So the way blockchain stuff works is, you send a transaction in Ethereum specifically, it has to be mined, meaning that people, take their computers and then like they mine it. There's different protocols, proof of work, basically they do some algorithm, or guess a number specifically, and whoever guesses the right number, that's the block that's mined, right? That's proof of work. Ethereum has switched over something else, I think maybe proof of stake, meaning basically there's certain computers that have like the data of the blockchain, the history of the blockchain, stored in like cold storage, more or less, or some type of like storage, right? And, if someone wants to verify transactions, let's say you want to send Ethereum to me, right? It verifies that you have it in your account. And then if you have it, then it says, yeah, this person has it. I have this record. I've been storing it here. I get paid for storing records and verifying records for people. And then like, boom, then like, the transaction is approved, but if you're doing some fraud stuff, they'd be like, hey, I have this record here. This person's lying to you, right? That's proof of stake. So all that being said, right, like it's not instant when none of this stuff happens. Therefore, if you write your smart contracts wisely, right, then when you have a transaction, like let's say for creating a token, for in this example, then you will emit an event, right? And that event can like have certain things like the token ID, like who created it, who has access to it, whatever you want, however you want to structure your, events. Like it really is just like what it's it's like a function that takes 3 or 4 parameters, maybe tops. There's a limit to it, and then it just emits those parameters, right? And I'm pretty sure you can't do strings without any defined length, right? Because blockchain stuff, you have to conserve space, and then smart contracts have to know what you're dealing with before they start dealing with it. That's kind of the value of. Well, I mean, it's more of a constraint of blockchain, not a value. It sucks sometimes. That's it, man. So like we're gonna have this listener. It's gonna listen for this event, when this token gets added, and then it's gonna say, "Hey, man, I got this information, right?" And specifically in Sales.js, I have the code that's designed to listen inside the Bootstrap, and I'll talk about that in the last lesson too. Now we're gonna dive into the Bootstrap and the configuration and see what's good. So all that being said, let's jump into the code. I want to share my screen. So I do this. We're sharing stuff. People are seeing things. All right, what's next? So first thing we're going to do is let's go to all the things that matter. Specifically, I'm going to go to the sign up controller. So it's under here in entrance and sign up. I'm going to close everything else. Let me do that here. Cool. So this is a standard Sales.js controller for sign up. This was generated. I did not write all this code, right? And that's the beauty of Sales. Like, fuck writing all the code. Sign up is it's a thing that, is pretty repetitive as you go from different application to application. And so what I did here is this is the code that I added. I'm going to highlight this. Yes. This is literally at the end of all the cell stuff. This is the last cell stuff. This is all what I added. And what I do here is like in the inputs, when you sign up, you enter your full name. I create a token name with that. I just basically take your full name and like add the string token name to it. And then I have this thing like a deed. So like essentially the 721 token, the one I designed, it has 2 strings, right? One is like a public variable, like where if you want to see what's good, like what is this token about, you would go to the token object, you will look at the index, the token ID, and then you would see the D, right? And I meant this to explain basically basic information like, the organization and the block usage, what's the token type, and then the name of the token, and then the description, and then I add the URL to block you. Now you can put whatever you want in the string, right? But I like the idea of adding format and convention to things. I think that one of the opportunities here is to create convention and standards, right? And then so basically I just duplicated, make the description object equal to the deed. And like I want to make sure you guys know, and I think as you go through this code, I'll show you guys specifically where this could be used. But like there's a situation where like if you add and this is important, you guys know this, if you add like a constraint in a call function that says only a certain address can read it, the way stuff is built is you can put in any address you want in that from section in the transaction. You can say this transaction is from anybody in a call situation, right? And basically there's no way to, you can put anything in there. So that logic of saying, oh, this person is viewing this, to only show it to this person, I think that's more or less flawed in that like you put anybody's address in there. And then it doesn't super duper check to see like who actually sent it. And I can show you guys, like I said, in the code backend wise. If you're using MetaMask and stuff like that, you wouldn't experience that because MetaMask, it always says it's from your address. But if you're like a programmer, you're like, hey man, I want to say it's from someone else's address. What are you gonna do, MetaMask? Or no, we're gonna do like Ethereum. I don't think Ethereum is really handling that situation. So I say that to say this. Any data that you guys put in the blockchain that you don't want anybody to see, like flat out, right? Or you want it to be more or less private for only certain people, you should definitely encrypt it with some form of a hash. and then there should be an outside key that you guys store somewhere else that someone can't see, you know, equivalent to a password, whatever you want it to be, right? And then basically, even if someone sees the data, they can't decrypt it because they need the key to do it, right? That's very important that you guys remember that. That's about it. That's kind of how passwords work. You know, WordPress has similar situations. Like there's this SH5 configuration encryption thing you can do, and I think WordPress takes like, it uses that more or less, but then also has this other like salt key. That's what it calls it, and it's just like that key I was talking about. It's like a password that's unique. And usually, like, you know, that's for if someone wants to see your password in a database. Usually supposed to be encrypted, but if they know how to decrypt it, then that defeats the purpose, right? So you need something to like extra encrypt it. You can call it two-factor authentication, more or less. You know, more or less. It's similar, not the same. All right, so let's proceed, right? So the logic of this situation, right? I created a helper in the tokens folder called create, and it takes in the user ID and it takes in the token, which is like this data right here, okay? So let's go to add token, right? So we're in the API folders, we go to helpers, we go to, let's see, we go to token, right? And then we go to create. It's like right here in the middle, or right in the root of this. And so this is like a helper function in sales. Like I really like sales, I like these helpers. It's like basically just kind of like a function, right? But it's compartmentalized so you can name the function what it's supposed to be. And you know, sometimes you have thousands and millions of lines of code and stuff, and it's nice to have it like in an organized manner. So that being said, it takes these parameters of the user ID, and then it takes the token name, or it takes the token information. And here's the user ID. It finds one. Look, that's how you do like finding modals and cells. It's how you query the database for a user. You know, very simple. And then I have this Ethereum address. I set that there. And then here's like the info object. And then there's information that's in it right here. That stuff. Owner ID. That's like my ID. I don't even think that's super necessary. Let's see, it's not even used. None of this is used. Owner is used, right? So I have my owner public key stored in my configuration. And I do pull that out because that is going to be helpful. I create this random key. That's not even super necessary. What's important is that I have this object right here, this database object, right? Or it's not a database object yet, it's a JSON, right? And I'm going to create it with cells using token.create, right? Token is a model. User up here is a model, right? And what I like about cells is this is how quick you can submit some information to the database. Let's take a look at this model, see what's good. So in this model, we gotta go to models folder under API, and I click token. Right, here's my token model. You know, it has some stuff, it has some information. You know, notice all the information that it has here, I didn't set because it's not required, right? You can make stuff required, like, oh yeah, I have this here. No, there's nothing here required. But it's required false, right? So you can make it say true, and it would make sure that it has it when it comes in, right? Look at these embeds, right? Basically, embeds are similar to like a foreign key, or a list of foreign keys. And basically that's what kind of collection is, right? Collection is like a list of addresses. I have an address model right here. You can see that right there. And that's cool, right? You can populate this. We can go more into sales maybe in a different video, but yeah, like it's a very nifty model setup that lets you easily kind of populate stuff. Look at this right here. It's like user ID is a model, and then it's the model of the user ID. And like when you want to set it, you just set it equal to the user ID you want to set it to, like so, right? Like right there. And then boom, it just creates it and knows what's good. It comes out. Look at that console log. We're going to see that console log at some point. So, look out for it. Cool. So that's the creation of a token. And what's next? So once it gets code, this is how my code works. So boom, we have this token in our database. I want you to notice how it says must manage true, right? I have this task that is called Mint, right? It's one of my helpers, right? It's under my helpers token inside the task folder. Specifically, it's the Mint task. And if you look at this logic, so here's some more cool sales logic, right? You have token.find, right? This is how you search for stuff in the database. And then searching for tokens that have the column or the value must mint to equal true, right? It's like, this is the where clause. And so it gets a list of tokens that, matches this clause. And then, this line right here, like, this is for a situation, more or less where, like, let's say something was minted for some reason, but this library ID, which is really the token ID in the 721 contract that I created, if that was 0, that means that's a remint or something like that. I basically added that it was at some point the library ID was not set initially, right? But now it is, right? But I have that there's fail safe, I guess, right? But I'll show you guys how that gets set too, right? So specifically, once it gets all the tokens that need to be minted, it goes into this for loop right here, and then it runs into this mint function that I created. And the mint function specifically just takes the token ID, right? So let's take a look at the mint function. It's inside of, let's see, methods, mint here. So in this function, it takes a token ID. It takes an optional callback. I'm not really using the callbacks yet, but you can have optional callbacks if you want, whatever you want in sales for the most part. And then, so we have this, I get this is token book, or no, token bank is not necessary. Token book is necessary. What this is it takes this is the address, right? In the backend, in my configuration file, that's the address to my 721 token. Token book contract is just the name of the contract, right? Tether book is not necessary, none of that stuff necessary. So I do have the owner and the owner PK, primary key. That's right here. Definitely like make sure you guys store that in like your .environment file, and you want to make it so it's like definitely not in your code. You don't want your private key out here, period. Right? So you want to keep that close to your heart. There's some other stuff that's not necessary. Let's look at this. So we have this, it finds a token and does that. That's cool, right? Basically, if the status is minting, it returns. It says, all right, so if this is already in the process of minting, I'm not going to like remint it, But if it's not in the process of minting, it continues. And then basically what it does is it updates. And one thing it does is it set minting to false. It identifies the library. For me, the library is the address the token is stored in. So it's the 721 contract address. And yeah, some other stuff is not necessary. We're going to talk about bank address, tether book, payment problem, none of that's other stuff for other lessons. Really cool shit though. All right, and then we change the status to minting, right? So this, and then this is the only important thing you guys should know. And then this right here too, right? So then we have helper create, and then, just console logs the name. That's cool. And then I run this function, right? It's another helper. It's the method's called add token. Now I want you guys to definitely take note how many helpers I'm calling, man. Like you may be like, wow, Tony Sparks, you got so many helpers, man. It's like you're the Salvation Army. You see what I did there, Stuart? Yeah.
Yeah.
I got jokes, Stuart. So yeah, anyways, yeah, I use a lot of helpers, right? Helpers are very helpful. That's why I use them. But like, it's good. It keeps my code all clean. Imagine all this stuff in one place. It'd be ridiculous. So let's go to add token. So it's under my methods folder. And then, so boom, right? What does this take? It just takes a token ID and an optional callback. It gets stuff. The owner gets the token book, gets the contract, gets stuff that's necessary for it. Token ID, just it gets that. It finds a token, right? It takes the JSON that I created back in, sign up, right? Look at that. Look at this deed. I created this, I initiated, I added it right here. Basically, it takes the information. right here, and then it creates a JSON string for it. And like storing JSONs and strings in a blockchain is just like, I think it's ingenious. Like literally, I think that it could be the start of like a blockchain database if you want, like something like MongoDB, you know, object-oriented database. If you can store JSONs in the blockchain, you can store, you know, database stuff, object-oriented database stuff in the blockchain, right? And that's kind of what we're doing. So boom, I take these arguments. These arguments are the owner ID or the owner address. I just kind of add that, you know, in the various places. And then I take the J or the D JSON and then the description JSON. You know, you can make your 721 token any way you want to. Mine takes these parameters, right? Basically just gives different people access. That's cool. And then, so I, you know, I did the council log right here. And then here's a cool thing, right? I create this transaction. Now, I want you guys to take note how basically I create this transaction right here. Add method is the method I'm calling. Arguments is like basically these arguments right here. I can store that in the blockchain. I can show you this transaction model too. This is a transaction model I created. And then I have the from, and then I have the app ID, which isn't necessarily a situation. And then I have to, it's going to the token book address contract. And then I have the contract name, you know, that it's in my code knows it as. And, you know, just to show you guys this transaction model, let's see, it's right here. You know, so I have the status, I have the contract value, I have the hash, like the transaction has, the method, like what's being called, the arguments. Notice how it says JSON, right? So this is cool. You can store JSONs in the database, using Sales.js or whatever. It's just an object of arguments here. And then you have this other raw transaction that's in the JSON, signed transaction. These are JSONs, and then a receipt. These just JSONs, right? JSONs everywhere. And then you have from and to, which are two different addresses, right? So this is the structure of my transaction model. So let's see. So now we have this code right here, signed transaction, right? And then so this is another method, and basically this takes this transaction ID, right? And it's going to create a signed transaction that is basically ready to be sent to the blockchain. And we can pull that up. Let's go over to, this is here, it's a transaction ID. Yep, it finds the transaction, and then it has the methods, it has arguments, it basically pulls it, and then initiates all these objects right here. Basically, if it's if the from owner equals to owner, so basically if it's coming from my system, then basically I use my private key and my owner public key. If it's not coming from me, let's say, so in this situation, right? When we create a user, and I forgot to show you guys this. I want to show you guys that. Just want to make sure I lose this. This is sign. All right, cool. This is sign, not sign up. In sign up, when someone creates an account on your website, you can use this function right here, web3.eth.accounts create. That creates a public and private key. And notice how it's not asynchronous. You don't have to use a wait or nothing like that. And that's basically because to create like an address and a public or private key, it's just like, it's, you know, it's just it's a pre-wrote function, right? And it takes some parameters in, I feel like, to add some randomness to it. But ultimately, you know, once you have this Ethereum address, basically the first, one of the objects of it, address, is the actual public address. And then the other object of it is private key. You know, notice how I store this here in like a hash password situation, you know, just in case someone wants to see it by glance, right? Then like it's at least encrypted so they can't just see the full thing, right? So yeah, I say all that to say this. If this transaction is coming from a user on my website, then I use their private key to sign it, you know, just to kind of, you know, differentiate that this isn't my system, this is their system, whatever, or the account that I created for them on my application. And like, you know, one of the reasons why like I think MetaMask is cool is that like if someone's like doing stuff, if I have this decentralized application, I have your private key. Technically, I can send stuff to the blockchain on your behalf, right? Exchanges work that way. Coinbase works this way. You know, all the decentralized applications do blockchain stuff. They more or less work this way. They don't tell you to say sign up with the MetaMask and add your private key and stuff like that. And the value of this is that, like, let's say worst case scenario, you're like, yo, man, I lost my private key. You know, I'd be like, all right, it's cool. We have our big databases backed up so many different ways. You know, we got you, right? So it adds security to like what you're doing, and kind of adds like a safety net, right? And you know, you need that sometimes because like if your stuff gets lost, you know, your private key, then you're just locked out for real, right? Especially if your MetaMask seed phrase is lost, all the bad things, right? So let's proceed. So we have this get contract function I have. All right, and then basically this is inside this Web3 little folder I created. What it does is it takes in the type of the contract, and then it takes in the address of the contract. Let's see here. Okay. Yeah, so type, it used to be in a situation where like, you know, this is for my code. Used to use truffles for this example. I kind of just more or less disabled it. I just wanted to focus on my system. But like I will point to the build folder in truffles or that truffles produces, and then I would go to the ABI here. But I created the ABI in this config file. I showed that in lesson 4, but for this lesson, I'll show it here too. Let's go to config. All right, this is the ABI for ERC 721 that I created. And so, okay, one thing about cell or like this UI, this editor is to hide stuff. Let's see. Where was I just at? I was at helpers. I was at token get. All right, cool. All right, cool. Wait, let's see. No, I wasn't here. I was inside of here. Okay, cool. Just close this. Yeah. So instead of typing use, really, it's just always going to be like this 721 ABI, which is good for this example. It doesn't matter, right? And then so boom, here's the real magic. Here is Web3, finally, right? And we're using the contract and to initiate it, we take the ABI, we take the address, right? Now we have a contract object. This function specifically just gets it, right? And then returns it back. Let's go back to where we came from. Here, right? So now we have a contract. And specifically what I do here is, so here's, now this is like definitely where the value is of this lesson and like what I'm teaching you guys. Cause it took me a while to get to this point. Like to send contracts to the blockchain, signed contracts to the blockchain from the back end. Oh man, it was an issue. And like one of the things I learned, right, is the ABI, right? Methods.abi, that's one of my helpers. But when you send a call to the blockchain, specifically, not a call, like a transaction that changes something, right? The data that you're sending, you have to create an ABI for it, right? It's like some type of data. It's probably like a hexadecimal situation. And it takes the information and then it submits it to the blockchain like a format that it can read it in, you know, something somewhat binary or something like that, application binary interface, ABI, that's what it stands for. So, you know, your methods and the calls you send have to be encoded in some type of a binary interface. All right, cool. So let's see what this function does though, right? So we're looking at contracts. So Web3, let's go back to this. Web3 contracts, then we have ABI. This is here, right here, right? And so basically it takes the contract, it takes the method, it takes the arguments, it takes all this information. All this function does is kind of like, it formats my arguments. You know, sometimes I have strings, sometimes I have numbers or whatever. You know, it just formats it, you know, in a way that it can be used. And then I have the arguments here, console log stuff right here. And then I call this, I have this string, right? So this string is basically, it's a call, right? And, or specifically, I'm executing the encode ABI function, right? And this is a function that when you're creating an ABI for the methods that you want to send, right? That binary interface I was talking about, then you have to call this function. It basically takes in your arguments, it takes in the method you want to call, and then it creates the ABI, and then it sends it, right? Or not, it doesn't send it, it gives it to you, right? Returns it right here. Well, let's say what this does specifically. This is a string, all right? I don't want you guys to think it's not a string, right? But I use this eval call, and that's dangerous. I want to clarify. You guys want to definitely make sure whenever you use this specific command, it's nowhere where outside code or outside input could come in. Because if someone wants to put some like malicious stuff right here in that like this call string and then have it go to this eval situation, you can be fucked, right? Because it could say stuff like, you know, cells find and then delete, right? You know, or cells destroy, right? All. It can do that, right? If you're not careful, right? But I'm careful, but I want to make sure you guys are careful too. So anyways, this function, and I also want you to make sure you guys know this object contract. One thing that's cool about this is, you know, this is an object that's inside the locality of this function. And when like eval is called, it pulls into objects or variables that is like inside the locality of where it's called. So if any global objects or whatever, this is kind of like a global object for this specific like function right here. I won't say global, whatever. But you know, eval has access to that. So that's why this works, right? This is there's some complicated shit. I did that to be dynamic, right? I don't want to have to write different ABIs for different calls. That's a trap, right? I was like, how can I do this one time? And that's what programming is about sometimes, you know, refactoring code, being efficient, being effective, right? And I'm a good developer, right? And I feel like you guys can be good developers too. Or you probably are, right? But now you're learning from me, right? Don't block me, block you. So anyways, you know, let's go back to where this is getting called. So boom, we have the ABI right here. And then so now we're basically able to create this transaction. So here's another helper, right? Inside of Web3, so let's go to Web3. Then let's go to, what is it? Web3 transactions create, right? So this takes the from address, to address, the encoded ABI of the method that you're trying to send, and then the value. Let me just see what I sent. Back right here. I don't think value is necessary. Yeah, that's why it's required false. It's not necessary. I'm not even sure what I use that for. Let's see. Oh, yeah. So if you want to send Ethereum with the call, and sometimes you have to do that, like I think specifically like a payable function, or if you just flat out want to send Ethereum to somebody, right? Then that's what that value is for, right? That's why it's optional. A lot of times you don't need to do that. But if you want to send Ethereum, then you have to set that. But let's go more to this, right? So what do I set here, right? I get the from address, to address, the encoded function ABI. I have Web3 object that I created, or like it's the Web3 library that I just have right here for use. And then I have the gas limit and then the gas price. So gas limit is like, yo, so let's say for some reason this function is in a weird for loop and you can't tell before it gets sent. And like, let's say the for loop does some weird stuff and causes a whole bunch of gas, like a whole Ethereum worth of gas. You're like, hey man, I don't want to spend that much money on my transactions right now. So I'll need a limit, right? That's what the gas limit is for. And then gas price, you know, I guess as the Ethereum price fluctuates, goes up and down or something like that, that you can make a limit based off of the price you're willing to pay. That's just stuff, right? These are just configuration things I have set in the back end. You know, the stuff that I do, I more or less understand that it's not going to be over a certain limit, certain amount. And so that's what I set here. And so let's see here. We have this Announce. All right, so this is an interesting thing, right? What is announce? So what's cool about blockchain stuff is like it goes in an order, right? It's like this transaction happened and that transaction happened. This transaction happened and that transaction happened. So forth and so forth, right? That's how Bitcoin works. That's how Ethereum works, right? And now it's like a specific uh, order of transactions or a specific ID. Like if you, let's say you send a transaction, and like I want to clarify too, the announce is specific to you in a situation, right? So let's say you send a transaction and it goes through whatever. Your announce was probably 0 and now it's 1, right? Let's say you send another transaction. Now when you get the announce, it's going to say 2, and then, you do another transaction. Now it's going to be 3. It's basically like, what transaction is this for you, right? Is this your 100th transaction or your second transaction, right? And it's important for that to happen or for this to be set. So you have the announce, and then you have, let's see, gas prices. That's cool, undefined. All right. Let's see what this is. Config is that. There's a function defined. Gas price. This says gets the transaction count. There. Okay. Get trans from, and then it says sales. This does this from. And then else, and then let's see this, undefined. So the reason why this code is here right here, and I'm gonna just tell you what it does. It gets like a gas price, and then it also it adjusts the gas price, more or less. And so what happens is if you send a transaction that has the same data, specifically like literally the same gas limit and the same price, Ethereum rejects it. And I think it does that, in case someone accidentally like writes some type of weird for loop that, or some type of like air bug in their code that sends the same transaction twice, right? And they're like, hey man, you probably don't want to do this. So like, we're going to prevent you from doing that. And so like the only way to kind of like prevent, or to like, if you really mean to send the same transaction types or whatever, is to change the gas price, right? And that's what this code does. And so just so you know, apparently you can set config variables in cells like during runtime stuff, right? I discovered that while doing stuff, I had this problem. I was like, hey, how can I dynamically store something in configuration for a specific user? This is the answer. All right, cells is very powerful. That's why I like it. So then you have cells, config, Web3, announce. It just console logs that stuff right here. And then basically it creates this raw transaction object for you. I want you to take note of this Web3 utils number 2 hex. The announce has to be in hexadecimal. Hexadecimal is like binary, but compacted or compressed. I think 1 hexadecimal stands for 16 binary points of data. All right, so anyways, here's this raw transaction. I just basically create the object, and then I return it back. Turn it back in the sign, and then we have this raw transaction, and then we sign the raw transaction, right? And so we need the sender private key, right? And then we take the transaction. This is the actual transaction object, right? The raw transaction. And then we can see what it looks like to sign something. So let's go to Web3, transactions. Then we go to sign. And we're here. And it takes the raw transaction, the private key. Also initiates the Web3 object right here. And then this is the code to basically sign a transaction. Ethereum account, sign transaction. You take the transaction, take the private key. And then basically it returns the result of it. And then this utils, this is an encoding function of the raw transaction. Pretty sure that SHA-3, that's an encoding function. Takes that, it returns that. It returns the hash, right? Raw transaction. And then this text hash is basically is in this object. Okay, let's see. Let's see exactly what's going on here. So you have this hash, and then this assign transaction, and then that's this thing right here. All right, cool. So it takes this, let me see, assign transactions right here. Okay, cool. So this creates the signed transaction outside of this function, and then inside the function, it takes the signed result and assigns it to it. And then it takes the information, passes it to the next, like then, like these are promises, right? I don't know if you guys are familiar with promises, but it takes then, and then passes the object to the other then clause. And then like basically it takes this hash, basically this is like how you get the hash of the signed transaction you created. And then also take like the original signed transaction result, and I put that in this object too. And that's what I return, right? And so you can see that right here. Okay, signed transaction. So it says this, it says, so it signs it, there's just info. So I have this signed transaction info. Here's the transaction hash right there. Here's the signed transaction actually right there. And then, so this is what I do here, right? The reason why I do this is if I like send a transaction to the blockchain, sometimes I want to double check the progress of it, right? And so in order to double check that progress, I need some type of ID. That's what the transaction hash is. The transaction hash is a unique ID for that transaction. And I just wanted to make sure that this transaction had that hash. And then it stores the raw transaction in JSON format, also the signed transaction in JSON format. And then the status is pending, right? So this is basically what I did to sign this transaction. And I updated the transaction data in the database. So I returned this updated transaction. So we're back to this add token situation, right? And let's see where. So now we have a signed transaction. Like definitely take note, man. Like this one helper function right here literally just legit caught 5 or 6 different functions. And that's why it's useful to use helpers, because like all that code be literally right here. So let's see what we have. So we have this method pages. All right, cool. So this is what I do now. The way that my contract is set up, meta pages is a number. It's like a count. I use that for a count. It basically records how many tokens are in my contract. And specifically, it's like off one or it's up one, right? Like if it says 3, it means there's actually 2 in there. But the reason why I have it say 3, and this is why it's useful, is that when I make this call to the contract to read and get that the ID of the count or whatever, I get this like library ID, and this is going to be the ID of the token that I create. And like one thing I want to show you guys or stress, right, is because like the way websites work sometimes is like, someone may send a request right at the same time, right? And your code and like this specific variable, like if it happens at the same time, like it will both come back with the same number, right? So the current number up next or whatever is 3, they will both get 3. And then like that would then get added to this to the token, right? And then my database will be thinking that there's 2 IDs or 2 tokens with the same ID of 3, right? So what I do to specifically avoid this is I basically queue up my transactions to happen one after another. So there's no matter if people want to do something at the same time, it still comes up with 2 different IDs, and then one happens one after the other. That way, like when I'm adding these tokens, I never have to worry about someone having the same ID just because they click the button at the same time. All right, so then I don't want to breeze over this call function because it's kind of dope too. So let's go over, check it out. So we have methods, we have call, let me just make sure I'm on the right one. So it's just here. This is, methods call, yep, this is it. And then what this does is it takes the contract, the address, the method, the arguments, because with calls, you can add arguments, like what token ID you want to look at or whatever. And then so it goes to the get function. I showed you guys that already. And then specifically goes to the methods call function. And that's inside my Webs 3 helper methods. And then it's, let's see, contracts methods call. All right, cool. So this is when I was talking about how you can send a call from the address that's not your own address or whatever. Like this is what I used to test it, right? And this is it, right? I used to just have it as my owner address. And I was like, hey, what happens if I put someone else's address in here? And it worked. And I was like, oh shit, this isn't super private, right? So remember that shit. So we have this contract, we have methods, we have arguments, right? The stuff I take. This is another call. Like I just format my inputs so it's like in a way that it works well inside of this. And then this is like where another situation where I use eval, right? And then like definitely like this is a situation where this is only called for my code, and like the stuff that comes in here is not like outside stuff. This is all stuff that's like internal. So that's why this is okay. And then I send a call from the sender, right? And then it gets evaluated, and then the results of this gets returned. If it's like a hexadecimal, it converts it to a number. Sometimes that happens, right? And then it returns the result. So we're coming back to here. And basically, I did that call to get the library ID, in which case I stored over here. Notice how all these are highlighted. I press Command D, and that's why visual code is dope. You know, I can change this all if I want to, but I don't. All right. So now we have this updated token. It has the updated hash. I call it the minting hash, right? And then it has the token library ID, the ID it will have, and it has the transaction ID, the transaction that would be sent. And then so I have this other method that says send signed transaction. We can check and see what that does. So we go here. So it says methods, send signed. It takes the transaction ID, gets the transaction. It sends the transaction. Web3 transaction send. So let's go to Web3 transaction send. Right? Takes this information, methods, arguments from to contract. Let's see here. So wait, let me just double check. So this is here. It says signed, send signed. Oh, yeah, no. Ha. Almost got tripped up. This is a send transaction for sending a transaction, not really sending a signed one. I have to go to specifically send signed. So it is, just follow the logic. So methods, helpers, token, methods, send signed here. Okay, cool. And it just takes the transaction ID, and then it takes the signed transaction, then it sends it. All right, and I guess it does use transactions or Web3. Cool. Web3 transactions send. Cool. So here's the signed transaction, and then it takes the code, or it takes the transaction right here, and then this is the actual Web3 object or function that sends the signed transaction, right? You guys should check the documentation. It's there. I did it. I found this. I use it. I did it for you guys. That's the value of Tony Sparks and Block U. I do a lot of coding for you guys, you know? But anyways, here it goes, right? You can send a transaction, and then it basically sends a transaction. And then this, let's see, it says helpers, Web3, transactions, update hash. I'm pretty sure this just takes the hash and updates it in the database, but I'm going to verify that. So transactions, we're Web3 transactions, and then, let me see. All right, cool. So we definitely want to wrap this up soon. Let's see, update right here. Yep, boom, just updates the transaction hash. All right, cool. So now we're back in the signed transaction that was sent. right? Basically, the transaction has been sent. Like the hash, the minting hash has been updated twice, more or less. Whatever, sometimes it happens. And then you have token update one. I update that, update it with the receipt, and then the transaction ID. Okay. And if there's any errors, then like basically I say, hey, there's an error. You have to go through the minting process again. So it sets mint to true, right? And then that's it, right? So that's the update situation. Basically, this is like the function to add a token, right? A transaction has been sent to the blockchain, right? So let's see where we're at. So we did add token, we did models, we did the mint. There's a cron job. So let's see where we're at. So now we have a situation. I feel like it's about time that we talk about where does the mint function get called? So like I have this task that I mentioned before. So let's go to token. Let's go to helpers. Let's go to tasks, mint, right? This function looks for tokens to mint, and then it goes to that mint process that basically adds token. We just went through that, right? But where is it technically, right? So if we go to config bootstrap, right? Oh wait, no, I meant to say this. If we go to cron job, so this is something I had to install this plugin. I will show it to you guys real quick. Let's see where it is. We go here, right? Let's go to cells, JS cron jobs. You see it's in my history, and it's this one right here. So this is clutch, right? This is allows you to run cron jobs. Like if you want to run a script once a minute, once every 30 minutes, once an hour, once a day. This is, the magic you use for sales. Cron jobs are in a lot of places, right? It's not just a sales thing or a Node.js thing. So anyways, I have this here, and then this is like, I don't know if it's every second, right? It's a certain time. I don't know the cron format just yet. But it basically runs this mint task, that frequently, this frequently. All right, so we talked about the cron job, and then now let's look at bootstrap. So now that we're in the bootstrap phase, well, I want to show you, I have the listener, right? So now this is the important thing, very important thing. Let's go to listeners, let's go to add token. We can go to listen tokens, listen contract specifically. So what I did, this is the listen function helper. And what I did here is, there's this code, the code for my 721 token right here. Basically, I created this add token listener. It takes in the token object, or I'm sorry, the contract name, and it takes the contract address, right? And it passes to this add token listener. What does the add token listener do? Well, it takes the contract and takes the address. It basically gets the contract with that function I showed you guys. And once it has the contract or instance of the contract, then this is how you listen for a function. You do contract.events. The name of the method. Oh, no. The name of the event you're looking for. So in my contract, when the token gets added, the event he emits is add token, right? So every time add tokens happens, this code is looking for it, watching for it, listening for it, right? And then once it happens, then basically, I do some console logs of the data and event. The information that I had, like it's in return values. Like I mentioned that when you emit an event, you can emit certain like information or data, like the token ID, where it's from, anything like a string with a predetermined amount of space. And then that information will show up here in these return values. And, I take this stuff here, I think at some point, so this is like back before when like I wasn't creating or storing the library ID before I sent the token. I would rely on this to give me the token ID that was created, right? And I don't super duper like that way. So I kind of like did it the way I do it now. But that's what this is for though. Like when, let's say boom, right? This is where the concept of an oracle comes in. You guys can look this up, but specifically a smart contract oracle is like, you know, these smart contracts are constrained. You know, they are limited, right? You can't put a whole ass website in a smart contract. Therefore, sometimes you need like a whole ass website's logic in it. So what you do is an oracle would emit, like when a contract emits an event like this, an oracle would then like process the data, do some stuff, and then make another call to another smart contract or the same smart contract. An example of this is like, let's say domain registrars, right? Let's say someone submits their domain to the smart contract to be registered, right? And then the event is emitted and it says this domain wants registration by this person or whatever, right? Event information. There will be a website, aka Oracle, that will watch that. Once that transaction happens, let's say in this situation, they will like say, okay, someone wants to be approved for a website or wants me to register a website. Doop, 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 buttons, buttons, buttons. It's done, right? Now that it's done, I'm going to click a button and send a transaction back to the same smart contract and let everybody know that I verified this address. Boom, right? It gets sent. So that's it. Yeah. And that's why listeners are cool. And that's what Oracle is, right? And so I have a listener here that does this. I think we're about ready to test. Let me see. So we have Bootstrap. We talked about listeners. We talked about creating tokens, all the code for that, models, minting, the cron job. And we, you know, said this is for when people sign up. All right. So let's run a test. Yes. All right. So what I do for this testing situation, first thing I want to do is I want to start the sites. I start it here. This is a fresh terminal. I'm going to use NodeMon app.js. So like the root folder. All right. So starting up the site. Boom. So now it's listening, right? It's taking a break. These are two things that's in like the listener stuff, listener code that console logged. And then now let's go to the site. So we're going to click this specifically, right? We're going to go to this, block you, do this, sign up, right? Right, then we're going to sign up. Okay, then I'm going to do this again. And I think I'm going to say, what is this? I feel like this is 9. I want to say 9. It could be 8. I want to say 9. Do this. All right, do this. Do this. Do this. Do that. So that's doing stuff, right? This is what's happening in the background. See, I think we're in this one. Yeah, this is the right one. So boom, the tokens information, it was console logged, right? The deed information that was console logged, the description was console logged. The library, which is the 721 address, is acknowledged. See, it's doing stuff. It's doing this stuff here. It's that stuff there. It's this stuff. All right, cool. So looking to mint, right? That's the start of the mint function doing what it's supposed to do. Then we have the transaction. Here's a transaction right there. It says it's pending. It notes the contract. It's the token book. That's the method. Add token. Takes us. Oh shit! This is going to run out. Oh man! All right. So we got to end this quickly. All right. So then here's the arguments, and then there's the receipt. I guess it's not set right there. And then this is just more console log stuff. It's looking at my inputs and stuff like that. Arguments. Add token. While this is doing stuff, I can show you guys this too. So one thing we do to verify this is happening is go to the Robson test network. Okay. And then we search for this. All right. And then sometimes it doesn't happen immediately. Let's see. Let's see if there's any bugs. So this is the minting transaction. Maybe let's just see if it was a different transaction somewhere else. Let's just proceed real quick and see what the bottom of this code happens. So this was definitely sent in the regards to, like, look at this. This is information. This is like what transactions look like when you send it. I want to copy this. See what happens when I do this. Let's see. See, I guess this is different. Message hash. Let's see this. Okay, so this is looking to mint. So there's, right now, my code is listening for this. Let me copy this hash. Okay, so I'm gonna double check this. Basically, this was the code that definitely sent it through. I tested this earlier, and it's like waiting for the transaction to be sent or like to be like mined. But the one thing that makes me feel some type of way is that it's supposed to be showing up right here. That's the hash or whatever. You can verify some stuff too. So here's remix. Let's do this. So 7 right here. And then 7 should be empty because it's like the one that's supposed to be. Yeah. And then so 6. So that's the old one. There might be a chance this actually didn't get submitted. I'm going to just try this one more time. Worst case scenario, I'll just like upload the remainder, like the ending of this video. But like the code I showed you guys is like, you know, basically golden, right? It's like good code. And, you know, for homework and stuff, definitely you guys have to do this. Definitely start with the front end. I'll upload the last session and this session, but like definitely do MetaMask stuff for the first part. So let's log in. Now let's do sign up. That's what I want to do. Let me try this one more time. So I'm just do 20 sparks, 10. And I wrote some code to basically verify if a transaction was sent, and if it wasn't, it resends it. I just didn't add it for this. But that's, you want to do that, and there's ways to do that. You basically just like, you take the hash, and then you like query it. Like I forget what call it is specifically. But once you do that, it would tell you if it was like sent or not. And if it wasn't, then like you can just write, you know, write code to have it resent. Okay. So we're here again. Let's see what's happening. We have this right here. So this is stuff right here. And then it's probably waiting to mint. And so we have 5 minutes left before this video is over. Let's see if we can get down to the wire. While this is going on, I think, yeah, all the information I feel like has been said. There he goes, just trying something again. This says minted token. And notice how, like, I have that in my code for it to check for other minted tokens and stuff. And number 9 is right here. And that's weird because it shouldn't be like trying to mint it. It should have already minted, but it might explain why they get minted in the first place. So let's take, it says block hash. Let's see, transaction hash. Just copy this. All right, right? There you go. You remember when it didn't do that before? Shit was crazy. It embarrassed me. I was like, what's going on? I tested this, but now I'm out here, you know, I do what I do out here. You know, shit happens. I want you guys to understand that shit happens as a programmer, but you persist. You just work. You just be like, I'm gonna figure it out. Logic. All right. So anyways, this is doing stuff, right? Let's see where this transaction is. It says success. That's weird. I don't know. But let's see what happens, right? Here's what's important. Let's go to the listener. The listener is inside of this right here, and it listens, and it says on token added. And I added that string so I could search for it in here. Boom! Right? You know what that means? That means my code was listening for my transaction, and then it found it, and I was like, yo, Tony Sparks, I was listening, and then I got this. I console logged it for you. You know, and I showed you guys how to do this, like literally. You know, you have the whole entire code right in your face. And this is by block you, not block me. It's about block you. So don't block me. Block you. And then so yeah, you know, there's the information that was emitted, right? And you know, it has like the address stuff, like the admins, owner stuff, different stuff I added for my 721. And then it has the token ID, right? I feel like that's it. Like we got 3 minutes on this. I did it. I won. I won teaching people how to do stuff today. And I'm happy you guys are here to see that. Oh, look, Stuart. Thank you, Stuart. Thanks for clapping for me, bro, man. I'm over here trying really, really hard, man. You know, trying to make everybody proud and like teach people, man. I just want to add value to your lives. We can start like a blockchain coalition, and we can like show people how to write code, but then like we can make all the monies. Because developer royalties, man. Like I feel like at some point for our capstone project, you know, we want to work on developer royalties. We're like, we want to build an application. We're going to use a blockchain payment processor, and every time someone gets paid on our payment processor, they're going to pay us because we built that shit. You know what I mean? Royalties. All right, so we got 2 minutes left. You guys have any questions? Okay. Well, yeah, so everything is, you know, here. Hopefully it's more or less self-explanatory or Tony Sparks explanatory. And I got this meeting with this guy who seems pretty cool. He invests in stuff, but I don't know, I don't know if he's gonna invest in my shit yet. But anyways, this is it. I think I'm ending this. Don't block me, block you. Session 6, we're going to talk about technical discoveries. I don't know if this is recording anymore. I think it's ending.
It still is. Like it's close to the end.
All right. Well, I'm going to stop this and then